Okay, this is the first video for chapter 13.4 and a little bit about 13.5. We are moving on to definite integral. So in the last few sections, we talk about indefinite integral, which you will add a c at the end. This time we can find the definite answer for this integral. And then we will also use the fundamental theorems of calculus. So if you look at here, they say suppose the daily cost function for a small manufacturer firm is given to this. So this is the cost function between 0 to 20 units. The marginal cost, which you need to take the derivative, right, is just equal to 180. What is the change in cost as production increase from x equal to 5 to x equal to 10? So you can calculate that by plugging in 10 and 5 into the cost function, and then find out the change of cost between 5 to 10 units. Notice that we can also find the same answer using another way to do it. So this is looking in the change of production between 5 to 10. One way to calculate is just plugging it back to the cost functions. We're looking between 5 and 10. And another way to do it is like taking the integral and plugging in the value from 5 to 10, so they are equal to each other. So this is between 5 and 10, so they say this is the same as finding the area between those two numbers. The change in cost from x equal to 5 to x equal to 10 is equal to the area between the marginal cost function and the x-axis from x equal to 5 to x equal to 10. So using this relationship, we have the fundamental theorem of calculus. If f is a continuous function on between the intervals of a and b, and this capital letter F is any antiderivative of f, then we have the integral from a to b of this function. Dx will equal to, you can plug into the b values of the antiderivative, subtracting, plugging in the a value of the antiderivative. So this is the fundamental theorem of calculus, and f prime of x equal to f of x here. So when we are dealing with definite integral and the area under the curve, we say a is our lower limits and b is our upper limits, and we read this as the integral from a to b of the function. So if we are using that, and this equal to the area of the regions above a and b. So a and b are here, so we're only looking at the area above, and then we need to subtract the area below. So if you look at this graph, between a and b, the curve go like this. So when you need to find it, you will use R1 is on above a and b, right? And then R3 is also above the line, so those are positive value, and you need to subtract the area in R2 because it's below the region. So they say the integral from a to b f of x dx is equal to the area of R1 subtracting R2 and then plus R3. So we're going to do some example together on the next page. Hopefully that make it a little bit more clearer. Let's look at that. Okay, so I know the font size is a little bit tiny on the next page. I apologize for that. So we're doing definite integral, and they give you the area for this little region A and B and C. So we're looking at the curve, which is an upside down parabola, right? Like this. And between A and B and C here, and they categorize those area. This is your capital A, this part is your capital B, and this part is your capital C, right? Okay, so the first one say from A to B alphabets. So I need to have the first part is below the region, so it's negative 2.33 for the A part, and then adding the B part, which is positive, is above like 0, right? 10.67, and then subtracting below here again, C is 5.63, so together, I'm sorry, this is just from A to B, right, not C. So this is from A to B, so just this area and this area, right? So together we should have 8.34. Okay, the next one is A to C. So starting with, this is below, so negative 2.33 plus the second part is positive 10.67, and the C part is below the line again, right? So subtract 5.63. So if you use your calculator, it should be 2.71. So the last one is from B to C. So B to C, so I only have the below the line C, right? So it's going to be a negative. C is 5.63. All right. So that's how you do that part. The next part have some property. So let's look at this together. I know it's hard to see, sorry about that. So the first one say it's from A to A, so there's no area there, right? So that's going to be 0. From A to B, it's going to be the same as negative from B to A, okay? And the next one, if you have a coefficient, have a number here, you can pull that out. If you are dealing with more than one terms and they are add and subtract, you can break them in parts. And the next one, from A to C, we can go from A to B and add from B to C. So that's all they're doing there. So some basic property here. So take a look, make sure you understand them. Okay, the next part, they give you some information that you can plug it in to find the answer for the next part. I know it's a little bit tiny. This is 0 to 2, 0 to 2, 2 to 3. This is x squared, and this is x squared again. So the first one, between 0 to 2, 12 times x squared dx. So 0 to 2, right? But I need x squared, so I probably need to plug in that guy. But I can pull out the 12 out first, right? And then we will do 0 to 2 x squared dx. So the x squared dx is like 8 over 3, right? So I'm gonna have my 12. I substitute this whole thing using that, so it's times 8 over 3. So I can reduce it. Oh, sorry. 3 times 1, 3 times 4, so together we have 32. Okay, if you want to, you can pause the video and try it. The next one, 0 to 2, but it has add and subtract, right? Meaning I can break them into parts. So I have 0 to 2, 2x dx, so don't forget the dx. Subtracting, this is 0 to 2 again, this time is 6x squared dx, right? So if you have a coefficient, I can pull out the coefficient. 2, this is 0 to 2x dx, subtracting 6 times 0 to 2, x squared dx, right? Okay, so x dx from 0 to 2 is 2. So it means this is 2 times 2 minus 6 times. This is 0 to 2, but x squared, right? So this need to multiply 8 over 3. So that would give me 4 minus 3 times 1, 3 times 2, that's 16. So together is negative 12. So that's for B. Okay, hope that makes sense. Okay, when you're ready, move on to C. Oh no, this is so tiny. Okay, this is from 3 to 2. So 3 to 2, I don't have 3 to 2. So I have to use one of those property because I have 2 to 3, right? So I can make it negative and then change this from 2 to 3, same guy, x squared dx, right? So that's one of the property we talked about earlier. If you flip the lower and upper limits, you will multiply it by negative, basically. So x squared dx is going to be this guy. So, no, sorry, from 2 to 3. I have to be very careful. So both of them are x squared dx, right? But this is from 0 to 2, this is 2 to 3, so this guy. So if I use that guy, that would be negative times 19 over 3, right? So that's the answer for C. Alright, this is like exhausting because the font is so tiny, sorry about that. So this is from 5 to 5, so there's no area, so it's just 0, right? That's one of those property. And the last one, I can pull a 3, right? And this is 0 to 3 x squared dx. So looking at my here, I have x squared, but it's either 0 to 2 or 2 to 3, right? So I don't have 0 to 3. So somehow I'm going to need to break them into parts. So I'm going to say each of them get a 3 as the coefficients. The first one I can cite from 0 to 2 and then pick up from 2 to 3, right? And still both of them we get x squared dx, and then this is supposed to be adding together, and then x squared dx. Okay, alright, so x squared dx 0 to 2, I got 3 times 8 over 3, and then adding 3 times what is that, 19 over 3, and then I can reduce, so it becomes just 8 plus 19, so this is 27. Alright, so they're not super difficult, but you do need to know some of the property and how that works. Let's do one more on this videos, okay? So the next question is saying if they want you to find the area of the region shaded, which is under this curve, the curve is y equal to x squared plus 1. We want it to be from x equal to -1, that's your lower limit. X equal to 2 is your upper limit. So this is your lower limit, and this is your upper limit. Alright. And then when we refer to the capital letter F, that is the antiderivative of the function. Antiderivative of the function. Okay? Alright, so let's try that. We are finding the area below the curve and about the x-axis, right? So my lower limit is -1, my upper limit is 2, and then this is x squared plus 1 dx, right? So it will end up with the antiderivative of upper limit subtracting the antiderivative of the lower limit, okay? So taking the antiderivative of this, it will be 1 over 3x cubed, right? And then the 1 become x, and then I need to add a c, and then I need to remind myself once I'm done taking the integral sign is gone, okay? And then this is 2 and -1. So basically we are evaluating from x equal to -1 to x equal to 2, okay? So I need to use plug in 2, subtract, plug in -1. So let's do it. So on the test, make sure you show the step, otherwise I cannot give you full credit, okay? Plug in 2 raised to the 3rd power plus the 2 plus the c, subtracting plug in the lower limits, which we have negative 1/3 times 1 to the third, negative 1, sorry, positive 1/3 times negative 1 to the third power. What am I doing? I think in my head I just multiply them together. And then plus a negative 1 plus my c, right? So after a few time doing that, you will know the c is always going to cancel out. So for the definite integral, normally they don't even write the c at all. So the first one would be 2 times 2 times 2 is 8/3 plus a 2 plus c. Don't forget this negative belong to all of them, okay? So distribute the negative in. So your minus, I'm sorry, this is, let me do one more step. This is going to be confusing. This is supposed to be negative 1/3 minus 1 plus c, right? So one more step. We got 8/3 plus 2 plus c plus 1/3 plus 1 minus c, right? So the c got cancelled. And then we got these two add together equal to 9/3. These two add together is plus 3. So basically 3 plus 3 equal to 6 unit square. So this is our very first example of finding a definite integral. Basically, it's the same as finding the area under the curve and above the x-axis. Okay, that's the first video.